Hey guys, in this video I'm going to run through how to answer all the questions from paper 3 in the 2025 Year 6 SATs. Question 1. Circle the numbers that have 8 in the thousands place. So numbers, that tells us that there is more than one, and 8 needs to be in the thousands place. So first of all, you can see all these numbers have these little commas. These are called separators. So after the separator is your hundreds, tens and ones. The number directly before your separator is the thousands place. So if I highlight the thousands place in each number, it's this digit right before the separator. Now if we look at those, which one of those numbers have got an 8 where I've highlighted it? So you can see this one does, this one does, and this one does. So we've got 28,436, 8,325 and 608,231. These three numbers are the ones that have 8 in the thousands place. It is absolutely fine to highlight all of the numbers like we've done here, as long as you circle the numbers that you're indicating as your answer. Question 2. Tick all the numbers that are less than 1,050,000. It might help you to write 1,050,000 out. If it does, you would just write 1. This separator means a million. And 50, so we've got another separator here. These 3 digits, and then we've got these 3 digits. These 3 digits tell us how many thousands there are. There are 50,000, so there's no 100,000s, but there are 50,000s. And then these are just zeros. So that's what 1,050,000 looks like. This here is 1,400,000. We can see that that is bigger. 1,049,000. Already you can see, look, 49 is smaller than 50, so that is smaller. 1,060,000. Well, we know that 60,000 is bigger than 50,000. And here you've got 30,900. So 30,000 we know is bigger than smaller than 50,000. That is a smaller number too. Question 3. There were 15,961 people at a football game. Round this number to the nearest 100. Okay, if we're rounding to the nearest 100, I'm just going to write the number out large. 100 is this digit. So this is the digit I want to be rounded. It either stays the same or goes up to the next one. And we look at the digit after it, which is 6. That is 5 or larger, which means that my 9 is going to round up to the next digit. So instead of 961, this 900 is going to become 1,000, which means it's going to alter this 1,000 digit as well. So it will become 16,000. If we're rounding to the nearest 100, it means that everything after the 100 digit will always be zeros, but the 900 will become 1,000, and that 1,000 got added on to the 15,000. So this is 16,000. Question 4. Jack buys 2 kilograms of pears. Might need to highlight that, 2 kilograms. He spends £3.28. What is the cost of 1 kilogram of pears? Okay, so if we know 2 kilograms equals £3.28, I'm actually just going to write it out again. 2 kilograms equals £3.28. What must 1 kilogram equal? Well, we can see that 1 is half of 2, so we are going to halve £3.28 to get the answer. You can halve it by putting it in a bus stop and dividing it by 2, or you could halve it by partitioning. So if I halved my £3, for example, I know that half of £3 is £1.50, and then I can halve 28 pence. Half of 28 is 14 pence. Now I just need to make sure that my 14 pence is added on correctly to my £1.50, so I know that is £1.64. But I'm just going to show you, if you did it in a bus stop, £3.28 in a bus stop, divide it by 2, put your decimal point above the decimal point in your £3.28. 2 into 3 goes once, there is a remainder of 1. 2 into 12 goes 6 times exactly, no remainders. 2 into 8 goes 4 times. You can see the answer is £1.64 both ways you do it. Question 5. Point P is located at 5, 8 on the grid. and you can see that it is actually labelled for you. Point P is translated 4 units right, 6 units down and 2 units left. What is the location of point P after the 3 translations? So here we are given the original point P. We're told where it is, and it's also labelled for us. They've made it nice and simple. They've told us where it needs to move, so translated means it's moved. It's not a shape, it's just a single point. So this is a relatively simple question. We're just moving that point using these directions, and then we need to say where it is at the end. Now it is absolutely fine to jot down each of these movements because the final answer is what's going to go in this answer box. So for example, if we go to point P and we translate it 4 units right, all you literally do is go 1, 2, 3, 4. So it's absolutely fine to draw it in. This is not recorded as your answer because your final answer is written here. So 1, 2, 3, 4 right, then 6 units down, 1, 2, 3, 4, 5, 6. You're simply following those directions, and then 2 units left, 1, 2. So this is the final one. I'm just going to put P there. That is where we end up after the 3 translations. And then you just need to write in the coordinates of this point, which is 7, 2. So what this is looking for is that you understand what translation is and that you also are able to describe a point on a grid using the coordinates. Question 6. The mass of the empty truck is 2,250 kilograms. You might want to highlight some information. It is then loaded with 8 boxes. The mass of each box is 25 kilograms. What is the total mass of the truck and its load? Okay, so we are told that there are 8 boxes and that each of those is 25 kilograms. So we can first of all figure out the weight of these by doing 8 lots of 25, which is basically 8 times 25. So we can do that as a short multiplication, 25 times 8. So 5 times 8 is 40, 2 times 8 is 16, plus the 4 is 20. So 200 kilograms for just these boxes here. But we've also got the truck, because it says what is the total mass of the truck and its load. Well, the load is 200, but the truck is 2,250. So we need to add those together. So we're doing 2,250 plus 200. You might be able to do that mentally. If not, I would suggest, even if you're slightly worried about getting it wrong, just to write it down. Definitely write down the calculation somewhere. But I would also suggest you do the formal written method because that's often where you get points even if you make a mistake. So we're just going to do a very simple addition. There we go, 2,450 kilograms. Question 7, draw 4 lines, in bold 4 lines, to match each improper fraction to its equivalent mixed number. So there are 4 mixed numbers. Improper fraction, sorry, and there are 6 mixed numbers. So 2 of these mixed numbers will not be matched. So we need to change this to its equivalent mixed number. So the best thing to do is to calculate each of these as a mixed number. If you're not sure how to convert improper fractions to mixed numbers and vice versa, that is a skill you should practice and revise. Very important skill. I'm going to do it very quickly now. 26 divided by 4 is 4 remainder 2. So it's going to be 4 with a remainder of 2 means 2 quarters. If you were simplifying that, that would be 4 1/2. But you can see there is a 4 2 quarters here. If there wasn't, I'd be looking for a 4 1/2, so I can match that up. 27 divided by 5 is 5 with a remainder of 2. And 5 2/5 is up the top there. 30 divided by 4 is 7 with a remainder of 2. Again, that is actually 7 1/2, but 7 2 quarters is written there. 32 divided by 5 is 6 with a remainder of 2. And we have our 6 2/5 there. So that's how I would do it. And then you can see there are 2 that are left over. Question 8. Ken buys these 3 items, and we can see that there's pictures of 3 items, milk, cereal and bread, and labelled with their amounts, 80p, £2.50 and £1.15. So one of the first things I would note is that we have some things written in pounds, something written in pence, so we have to be mindful of that when we are doing calculating. He pays with a £20 note. How much change does he get? So change is what you get after you've paid the amount and you've paid more than you needed to. So the first thing we need to do is to calculate how much these 3 items cost, and to do that we would simply do an addition. So we could do a simple addition, writing in it clearly. Now 80p would be £0 and 80p. If you do that, then you are ensuring that you are adding in the same unit. So 0 plus 5 is 5, 5 and 1 and 8 is 14, put your decimal point in, 2 and 1 and 1 is 4. So our 3 items cost £4 and 45 pence. So that's how much Ken needs to pay, but Ken actually pays with a £20 note. So we're going to find the difference between £4.45 and 20, which is the same as subtracting. So when we subtract, put your £20 in with the pence, because £4.45 has 2 numbers after the decimal point, so put them all in like that, and you would simply do a subtraction. So we can't do 0 take away 5, we're going to have to go all the way over to our 2 and do some exchanging. This is one of the skills that you need to know in year 6. If you're not sure on this, then this is definitely something that you need to practice. So we're now just going to do a simple subtraction. 5, 5, decimal point, 5 and 1. So our answer is £15 and 55 pence. Even if you're not sure how to do the subtraction, make sure you write the calculations in. Another way you might have done it is with a number line. You might have, this is obviously a very messy number line because I have no ruler. You've got your £4.45, your £20 here. I would maybe round up to £5. So that's 55p. And then from £5 to £20 is £15. So it's £15 and 55p. Here is part of a number line. Write the number that the arrow is pointing to, and then the second part of the question is to write the number that is 16 less than 7. Okay, so what is the number that the arrow is pointing to? You can see there's a 0 here and a 5 here. That gives us our scale factor. I know that there are 1, 2, 3, 4, 5 spaces from 0 to 5, so I know that it's just going up in ones. Okay, so that makes it nice and easy. So if it's going up in ones, it's also going down in ones. Now on this left hand side of the 0, we would be having -1, -2, -3, -4, -5, and then -6. You don't have to label them, you can just simply count. I'm just showing this to demonstrate. So the arrow is pointing to -6 or -6. Write the number that is 16 less than 7. So you could find your 7 there, and you can count back 16 spaces and then get to the number. But what I like to do is go to 0. So from 7 to 0 is 7 spaces. We need to do 16 altogether. We've already done 7, so that tells me I need to do another 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to get me to here. And from 0, if I'm taking away 9, so 7 and 9, these together equal the 16. So that is my big jump of 16. From 0 to take away 9 is just -9. If it's easier, just count individually. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so that you know it's this space, and then count back from 0. But the answer is -9. Question 10. Here is some information about 4 animals in a zoo. And you can see we have a two-way table here. We have 4 animal names across the top. And then down the left hand side we've got information about the mass and information about the height. So we have mass and height of every animal. Tick the statements that are true. So we'll evaluate each statement as we go, and it says statements, so that means there can be more than one answer that's correct. The elephant is exactly 3 times heavier than the rhino. So we would go to the elephant and the rhino. And it's heavier, so we'd be looking at mass. 3 times heavier. Now, you should be able to do that mentally. 6,300 is not 3 times 1,100. You could do that in your head. 1,100 times 3 is 3,300. If you need to calculate it, you could do 6,300 divided by 3 or 1,100 times by 3. If it doesn't equal the other animal, then you know it's not correct. So that one is not correct. Next one, the hippo is a quarter of the height of the giraffe. So hippo and giraffe, and height this time. So hippo and giraffe. The hippo is a quarter of the giraffe. 1.5, is that a quarter of 6? It is. So you could either times 1.5 by 4 to see if 4 lots of that equal a giraffe, which it would, or you could divide 6 by 4 to find out if 1/4 of your giraffe was equal to hippo, and you would find that that is actually correct. So we could tick this one. The rhino is 20 centimeters taller than the hippo. So we're looking at height again. So we've got rhino and hippo. 20 centimeters taller. So got to do a bit of converting here. So the rhino is, if we look at centimeters, the rhino is 170 centimeters, and the hippo 1.5 is 150 centimeters. So you've got to do a bit of converting here, and then you can see that 170 is 20 more than 150, so that is correct. The tallest animal is also the heaviest. So here we would look for the tallest animal. So if you look down along your height column, the tallest is this giraffe. And is it also the heaviest? If we look at the weight, actually if we look across, the elephant is actually the heaviest, so that is not correct. So the only 2 correct statements are the ones that we've ticked here. Question 11, tick the number sentence that is correct. So there are 4 number sentences, and as it says the number sentence that is correct, and it says 1, we are just looking for one of these that are correct. So we're going to go through each one and evaluate them. Now we've got, you can see here, a variety of fractions with denominators 10 and 1,000. So there are a couple of ways you could do this. You could either convert these to decimals, then add them up, or you could convert these fractions so that they're all out of 1,000 and then change it, add it, then change it to a decimal. So if I show you first of all how to think of these as fractions first, so 4 out of 10 is the same as 400 out of 1,000. So 400 over 1,000 plus 3 over 1,000 we can add. That becomes 403 over 1,000. And that would be then equal to 0.403. 1,000 is 3 decimal places. Our first decimal place is a tenth. Our second decimal place is 100th, and our third one is 1,000th. So as there are 3 decimal places, it's basically saying this is the same as 304 over 1,000. So here 43 over 1,000, remember thousandths are 3 decimal places, so 43 over 1,000th is actually 0.043. 43 thousandths is equal to this, not to this. So that doesn't work, that one doesn't work. So for this one, if I do it this time changing it to a decimal, now you can stick to doing them all out of 1,000ths. I've already showed you here, 4/10 is equal to 400 over 1,000. Actually, you can see we've already got this answer. So if I do the same question but a different way, so you can see that it does work. 4/10 is 0.4 and 3/1000 is 0.003. And if we added these together, we would be doing 0.400 plus 0.003. If you added them up vertically, like that, you would see that equals 0.403, the same as the other way we did. If we converted it to a fraction over 1,000, then added them, or if we converted them to decimals and then added them. So this is the correct answer, but I just want to see it through. So for this last one, let's change that to 1,000. So 3 over 10 is the same as 300 over 1,000 plus 4 over 1,000. That is equal to 304 over 1,000, which is equal to 0.304, and you can see that's not correct. So the one that is correct is this one, and you would tick it inside that box. Question 12. Each clock below shows the time in AM or PM. These are in bold, so that means we need to pay attention to this AM or PM. Match each clock to its 24-hour time, and one has been done for you. So there is a demonstration here. You can see in this analog clock on the left that the time is 4:05. It says it's AM, so it's simply matched to the clock that's the digital clock that says 04:05. This is 4:05 AM. So you do need to know how to read an analog clock, and you do also need to know how to write time in the 24-hour format. So let's have a look at the second question. We can see that it's between 12 and 1, so it's not 1 o'clock yet, therefore it is still 12 o'clock, and it is 12:35. It says PM. We are going to go from this to the 12:35. Sometimes people get a bit confused with PM and AM when it relates to 12. Midnight is 12 AM, so that is 0000. So if it was midnight, if it was 12:35 at night, that would actually be listed as an AM, because that is as soon as it gets to 000, that is the new day, so that is the morning. That can sometimes be a bit confusing because we think of midnight as nighttime. Okay, so for this next one, we can see that the hour hand is pointing, it's past 7, so it's 7 o'clock, and then the minute hand is on 20, so it's 7:20. There are two potential 7:20s because this reads 7:20, but so does this. These both read 7:20 in the 24-hour clock. However, this is an AM, so it is this 7:20. So that's something you just need to be mindful of. And if we look at our last clock, we can see the hour hand is between 10 and 11, but it's not at 11 o'clock yet, so it is still 10, and the minutes are 45. So this is 10:45. It's PM. So 10:45 PM, we just add 12 to the 10. So 10 plus 12 is 22. 10:45 in the 24-hour clock in the PM is 22:45. Question 13. Write these numbers in order starting with the least. That is in bold, and it also shows the least here. If you happen to write the answers in the wrong order, you must cross out that least and put most, but please do pay attention to this and make them write them in least first. So to be able to compare these, we want to really be able to put them either all into decimals or all into fractions. So we can have a go at doing it both ways. So 9 out of 100 is 0.09. 99 out of 100 is 0.99. Now you can see that these are 3 decimal places, the other two, so we can simply make our 2 decimal place numbers 3 decimal places by adding on a 0 at the end. Now they are all the same, and now all you need to do is to compare these 3 numbers, and you can very easily see that 0.09 is the smallest out of these, so write it in 0.09. 0.009. The next smallest is going to be this 90, 0.90. So I'm going to write it in as it was, 9/100ths. You can write it as 0.090 because that's numerically correct. Now if I look at my last two numbers, I've got 999 and 990. So 990 is the next smallest. So that is my 99 out of 100. And then finally I've got 0.999. Now I could also have changed these to fractions. As these are 3 digits, if I just use a different colour, this would have been 999 out of 1,000. This would have been 9 out of 1,000. 99 out of 100 is 990 out of 1,000, and 9 out of 100 is 90 out of 1,000. Now if you compare them, you'll still see that 9 is the smallest, followed by 90, followed by 990, followed by 999. Question 14. Look at this expression, y plus 4. Tick the value for y that gives a prime number value for y plus 4. So what that means is, if y was worth these numbers, would the answer be a prime number? So y plus 4, if y was 8, y plus 4 would make 12. If y was 9, y plus 4 would make 13. And if y was 10, y plus 4 would make 14. It just wants you to show that you can substitute, you can swap the letter y for these numbers. So these are ifs. So which one of these is a prime number? Well, it's this one. So you would tick this box. Tick the value for y that gives a square number for y plus 4. So again, you're going to swap the number that y is equal to for that expression. This is called substitution. So if y was 5, then y plus 4 would be 9. If y was 6, y plus 4 would be 10. And if y was 7, y plus 4 would be 11. Which one of these is a square number? Well, it is 9 is a square number, so you would tick that box. Question 15. A factory makes t-shirts and dresses and they pack them in boxes. There are 50 t-shirts in a box. How many t-shirts are there in 250 boxes? So that's a nice simple multiplication question. If there are 250 boxes and 50 t-shirts in the box, you are simply doing 250 multiplied by 50 to get your answer. So you could do a multiplication like this. Obviously we know that that's all going to be 0, and then your 25 times 5, and then add it all up. So 12,500 is your final answer. I'm just not going to demonstrate how to do long multiplication because you should know how to do that, but it is a multiplication question. If you're not sure of the answer, just at least write that bit down. You can come back to it later on, or rather than having to waste time on the question if you're not sure straight away. Just write the calculation down as my suggestion. There are 40 dresses in a box. How many boxes are needed for 3,000 dresses? So this one is a division, okay, because we need to know, if we know how many dresses there are, we need to know how many lots of 40 will come out of that 3,000. So for this one, you are doing 3,000 divided by 40. 3,000 divided by 40 is actually the same as doing 300 divided by 4. So I'm actually going to do 300 divided by 4 instead. It is exactly the same answer. You don't need to divide down afterwards. So I know 4 into 30 is 7 with a remainder of 2, and 4 into 20 is 5. So 75. So if 75 times 4 makes 300, I know that 75 times 40, just to prove, makes 3,000. So there are 75 boxes needed. Just make sure you don't write 40 in here. The answer is 75. Question 16, this is a 1 mark question. These pie charts show the biscuits in 2 tins. Tin A has 36 biscuits, tin B has 20 biscuits. tin B has more chocolate biscuits than tin A. Explain why this is incorrect. So what you need to know about pie charts is that they can represent any total. So you need to look at the total. Fractions, you can't compare two pie charts based on just the size of the sections. If you look at the size of the section where chocolate is in tin B, you'll see it's half of the circle, but in tin A it's less than half, so you might be tempted to think that tin B has more chocolate because it's a bigger section, but we need to look at what the total is. So what you would do, because you want to show it's incorrect, is to actually calculate. So here you can see that chocolate is half of that tin B, which is 20 biscuits. So we know that there are 10 chocolates in this tin. Tin A, this looks like thirds. Chocolate, plain and ginger looks like there are thirds. So a third of 36 is 12 chocolates. So tin A actually has more chocolates, and you could literally say half of 20 equals 10. A third of 36 equals 12, and 12 is bigger than 10. You could literally just show that. You could say it in a sentence, so you could actually write about it, as long as you are showing that you have calculated how many chocolates are in each of the tins, and you clearly show you're working out for both tin A and tin B. That will get you your mark. Question 17. This question is worth 3 marks, so that means a lot of methods, a lot of working out to be shown. A shop buys 35 boxes of crisps. Each box contains 48 packets of crisps. So we've got an illustration here. Here's one box containing 48 crisps, but the shop is buying 35 of these boxes. On average, the shop sells 56 packets of crisps each day. How many days will it take for all the crisps to be sold? Okay, so let's first of all work out how many packets we have altogether, because we're working with packets here. So if there are 35 boxes of 48 packets, then we are going to be 35 multiplied by 48 to figure out how many packets there are altogether. If I just switch up my colours, I'm not going to demonstrate how to multiply. I will assume you know how to do that. If you're not sure how to do long multiplication, that is something you definitely need to revise. Lots of long multiplication questions. 3 times 8 is 24, plus the 4 is 28. It's right there. So once we have figured out how many packets there are altogether, I might just write it down. 1,680 packets altogether, and 56 packets of crisps are sold each day. How many days will it take for all the crisps to be sold? So it says on average, that means obviously some days are more, some days are less, but we are able to use that as a division. So we need to figure out how many lots of 56 fit into 1680. So you're going to do a long division. So 1,680 divided by 56. So I always list my multiples that I'm dividing by, first of all, as once I've got my multiples, that's going to be a lot easier to multiply, to actually do the divisions. So I know 56 is not going to go into 1 or 6. I'm going to look at the number 168 first. If I look down my list, it is 3 times fully. So you would subtract the 168, which gets to 0, bring your 0 down. How many times does 56 go into 0? It goes 0 times, it is 30. So it takes exactly 30 days for 1,680 packets of crisps to be sold. Question 18. Each of these questions is worth 1 mark, so the whole question is 2 marks. Convert 5.65 kilometres to metres, and then convert 35.5 centimetres to metres. Both are converting to metres. One's going from kilometres, one is going to metres. Now what I often recommend is if we're doing any kind of conversions, to avoid confusion, I would write what is 1 kilometre worth in metres. So 1 kilometre in metres is 1,000 metres. This is because it's very easy for us to divide instead of multiplying, because kilometres are bigger than metres. So sometimes people think, well, I need to divide it, but actually you need to multiply it, because 1 kilometre, to get to 1,000 metres, we are multiplying our number by 1,000 there, aren't we? So if we want to change 5.65 kilometres to metres, we are going to need to multiply that number by 1,000. So if we multiply by 1,000, my 5 is going to become 5,000. My digits stay together. So 5,000. What I like to do is convert my decimal point to a separator, a 1,000 separator. So my 5 becomes 1,000. 5,065. There's got to be 3 digits after this separator. So that's a 0. So 5,650 metres. So centimetres to metre, I'm going to think about, because I know that centimetres are smaller than metres, I'm going to think how many centimetres are in a metre. It's 100 centimetres are in a metre. So to get from my centimetres to metres, from that 100 to the 1, I'm going to divide by 100. So when I am then trying to convert my 35.5 centimetres to metres, I know that I am still going to be dividing by 100. Okay, if I divide by 100, each digit is going to move 2 spaces. So my 30 moves to a 1, then it moves to a tenth. So I know that this is going to be 0 point, and then my digits always stay together, 3, 5, 5. So this is really knowing how to multiply and divide by 10, 100 and 1,000, and remembering how many of each unit fits in the other. So remembering that there are 100 centimetres in a metre and that there are 1,000 metres in a kilometre. So my final answer is 0.355. Question 19. This question is worth 2 marks. Jacob has some wooden blocks that are all the same size. He uses the blocks to make 2 towers. They're all the same size, so we know that we can divide these equally. Not actual size important. Do not try and measure it with a ruler. The height of the taller tower is 22 centimetres. What is the height of the smaller tower? So as we know they are all equal, we know that we can divide these up. If this is 22 centimetres and we have 1, 2, 3, 4, 5 blocks, we simply need to do 22 divided by 5 to find out what each individual block is worth. Now you can do this using a variety of methods. You can use a bus stop to divide. I know that to divide by 5 I can divide by 10 and then double it. So 22 divided by 10 is 2.2, and if I double it I know that it's going to be 4.4. As I say, you could also use a bus stop here. I know that's going to be 4 with a remainder of 2, and then 5 into 20 is 4. Same answer. So if I know that these are all 4.4, I essentially know this. So to find the height of the taller tower, I need to now do 4.4 multiplied by 3. And for this, again, you can use a standard multiplication. You could do 44 times 3. And then as I've multiplied my 4.4 by 10 to make 44, I need to make sure I divide my answer by 10. So it's 13.2. Or you might do it as 4 times 3 is 12. So 0.4 times 3 is going to be 1.2, because this is 10 times smaller than that. Add these together, 12 and 1.2, and you're going to have 13.2. Same answer. Question 20. This shape is made from equilateral triangles. Okay, that's very important to know that they're equilateral triangles. That is telling us that all the sides are equal, that the angles are equal. What fraction of the whole shape is shaded? Okay, so we can see we have the triangle divided up into triangles, and then divided up, one of the triangles is divided up into smaller triangles. So what we can do here is first of all identify, we have these medium-sized triangles, we could say, like this yellow one. There are 4 of those, 1, 2, 3, 4. So we could first of all say that this triangle here is a quarter, the big triangle, and then within that triangle we've got 1, 2, 3, 4. So the quarter is divided into quarters again. We've got a quarter of a quarter, so it is a quarter of a quarter that we've got. To find what is shaded of can be replaced with a multiplication, so we have a quarter times a quarter. So you are simply doing a multiplication of fractions. When we multiply fractions, we multiply the numerators, 1 times 1 is 1, and we multiply the denominators, 4 times 4 is 16. So that little triangle that is shaded is worth 1/16. Question 21, this question is worth 2 marks. Here is some information about a number. It has 2 digits, it is a multiple of 7, and one of the digits is 8. Write all the possible numbers that it could be. So if you look down the list of criteria, think about which one has a limit first. So if I looked at it has 2 digits, well, I know that anything from 10 to 99 has 2 digits. That's a lot of numbers. If I looked at one of the digits is 8, that would limit those numbers, but it's still quite a lot of numbers. And then a multiple of 7, that also has a limit because it is the multiples of 7 between 10 and 99. Now it's up to you whether you would want to just look at the digits that are 8, because obviously you would go 18, 28, 38, 48, 58, 68, 78, but then you'd have to list all of the 80s and a 98, or whether you would do the multiple of 7. I would go with the multiple of 7 because I think there will be less of those. So I know that it is not going to be 7 because that hasn't got 2 digits, so I'm just going to quickly make a list of the multiples of 7. So I've made a list of multiples of 7, and I've stopped at 98 because anything after that is not going to be 2 digits anymore. So I know I've done 2 digits. Now one of the digits is 8, so we can cross anything out which doesn't have 8. So I can tick that. Write all of, and we know it's a multiple of 7 because all of these are multiples of 7. Write all of the possible numbers that it could be. So we have got 98 and we have got 84. If we look down our list, we've also got 28. So 28, 84 and 98. Let's just double check. Do they have 2 digits? Yes. Are they multiples of 7? Yes. And are one of the digits 8? Yes, that is correct. Double check your list to make sure that you haven't missed any out, and that's how you answer that question. Question 22. This diagram shows 4 identical parallelograms and a rhombus. Important to note it's not to scale. This means don't try and use your ruler or a protractor to do any calculating. You're using your understanding of the properties of polygons. Calculate the size of angle A. Now the fact that these are all identical parallelograms is what is going to help us to calculate this. So with a rhombus, so if this is something that you are unsure of, then you definitely need to be revising properties of polygons. So what I know is that in a parallelogram, there's always a pair of obtuse and a pair of acute angles. So I know that this is also going to be 115, and that the acute angle is going to add to 180 with the obtuse angle. So if the obtuse angle was 115, the obtuse and acute add to 180, so I know that this is going to be 65 because these two have to add to 180. I also then know that it's going to be the same in all the other parallelograms because it says they are identical. So what that's going to tell me is that this angle here and this angle here, these are both the acute angles. This is 65 and that is 65. And I know that these three angles, if I did a large like that, this angle here and this angle here create a straight line which is equal to 180. So I know if I add my two 65s together, so 65 plus 65 equals 130, I can subtract that from my 180. 180 take away 130 equals 50. I know that that central angle, the A, is going to be 50 because this angle A and this other angle all together create a straight line which is 180. So size angle A is 50 degrees. You would show you're working out down the bottom here. You would just literally show 65 plus 65 equals 130 and 180 subtract 130 equals 50. I hope you found that video useful. Please do remember to like and subscribe, and if you're looking for any more support with your SATs, head over to pocketprivatetutor.co.uk where I have tons of courses and resources to support you.